Here's your homework over 3 through 5, so we're going to be practicing some graphing here. Before I get to the graph, I always like to start with the horizontal and vertical asymptote. We can go ahead and do the domain and range as well. So the vertical asymptote, remember, that's found in your denominator. So that would be x equals 2. Notice I did flip the sign there. So the denominator said x minus 2. Then it's actually positive 2 for the vertical asymptote. Then straight from that, we can go ahead and infer that our domain is going to be all real numbers except x can't equal 2. So your vertical asymptote and your domain always go hand in hand since they are both x. And then while I'm at it, I'm going to go ahead and graph that. So we have a vertical asymptote at 2. All right, moving on to the horizontal asymptote, that's the last number in your equation, which is a negative 3. We don't flip the sign here. It's always y equals, so y equals negative 3. So your range is all real numbers except y can't equal negative 3. So those both are y, so that's why your horizontal asymptote goes with range. So I'm going to go ahead and plot that. So those are the bones of your graph, and then to get your actual points, you're going to create an XY chart. So you can really pick any values for your XY chart, but the best practice is to pick 2 x values to the left and 2 x values to the right of your vertical asymptote, which is blue on your graph. So 2 values to the left would be 1 and 0. 2 to the right would be 3 and 4. Then I'm going to plug this into my calculator, practicing the way that we did in class, or if you watch the notes video. So we did negative 4 out, and now I'm just going to change that to a 0. And then a 3. And a 4. And then I'm going to plot all of these points. So 1, negative 4, 0, negative 3.5. Okay, so they're all really close together, but that's okay because when you start graphing, you can see how they would connect to give you those 2 parts to your rational function. Remember, your graphs never cross or touch the asymptote, so be careful of that. All right, so looking at number 2, I'm going to start with the vertical asymptote. You can start with either, but I would suggest starting with the asymptotes. So switching the sign there, it'll be at x equals negative 1, which means your domain is all real numbers, except x can't equal negative 1. And I'm going to go ahead and plot that. And then your horizontal asymptote is from this number at the end. It's always y equals. So y equals 2. And your range is all real numbers, except y can't equal 2. So then we have to make a table. Looking at your vertical asymptote, 2 numbers to the left would be negative 2, negative 3. 2 numbers to the right would be 0 and 1. Plug those into my calculator with my equation. Getting out a 6 for negative 2. 4 for negative 3. For 0, the output's negative 2. And for 1, it's 0. So negative 2, 6. Negative 3, 4. 0, negative 2. And 1, 0. And we're going to connect these so that they get really close to the asymptote. Alright, so same process, just different numbers here at the bottom. Your denominator tells you your vertical asymptote. Remember to switch the sign, so it's x equals negative 1. So your domain is all real numbers except x can't equal -1. And then graph that. And then for your horizontal asymptote, it's at -2. Y equals -2. And that's all real numbers except y can't equal -2. And then go ahead and put that on your graph as well. And for the table, I'm going to start thinking about some numbers to the left and right of the vertical asymptote. So two numbers to the left then would be -2 and -3. To the right would be 0 and 1. I'm going to plug those into my equation there at the top. So for -2, I'm getting out -4. For -3, I'm getting out -3. For 0, getting out 0. And for 1, getting out -1. So I'm going to plot those points. And then connect them so it looks like a rational function. Last graphing example, so the last one on the front, your vertical asymptote should be at x equals 4, flipping that sign. So your domain is all real numbers except 4, 4. I'm going to graph that. The horizontal asymptote is this last number, so y equals 1. So your range is all real numbers except y can't equal 1. And now for your table, so think about some good numbers to plug in. I'm going to choose 3, 2, 5, and 6. So for 3, the output's -2. For 2, the output's -0.5. For 5, we get 4. And for 6, we get 2.5. Putting that all in the graph. All right. And we have our graph of our rational function. So if you flip over your homework, then we're going to do this big matching game. And so something that I always like to start with is thinking about where, I'm going to start with just the vertical asymptotes are. So I'm going to take a moment here, and on these problems, I'm going to go ahead and to the side, right where the vertical asymptotes are. So right now I'm noticing none of them have a repeated vertical asymptote. So we'll see if that continues to hold true. Okay, so we have 2 that have a vertical asymptote at -2. And we have 2 that have a vertical asymptote at +3. So we're going to have to hold off on, let's see here, 16 and 21, and also 18 and 22. But for the other ones, we can go ahead and find based on the vertical asymptote. So on 13, I'm looking for a vertical asymptote of 2. Make sure you notice your graphs down here go by a scale of 2. So the vertical asymptote of 2 would be here on 18. Okay, so for 14, the vertical asymptote's -1. So I'm just kind of glancing over these. Number 17 has a vertical asymptote at -1. 15, the vertical asymptote is at -4. So that goes with number 20. And then I have to come back to 16. So 17, the vertical asymptote is +1. So that's number 22. 18 I have to come back to, so 19, the vertical asymptote's at 0, so on the y-axis. So that would be number 19. 20, it's at -3, so it's number 14. And then on 21, it's at -2, which is number 15. Okay, so the ones I have remaining, it's because they have the same asymptote as something else. And so I'm going to go through and also write their horizontal asymptote. Oh, wait, hold on. I was not supposed to do this 21. Let's check if 21 is correct. So that should also have, yeah, that actually is right. So this one should have a horizontal asymptote at 3. And notice that number 15 does in fact have that. So the reason I was questioning myself is because that had a vertical asymptote of -2, as did number 16. But 16 has a horizontal asymptote at -1. So let's find the other graph that could be matched with that. So -2 and -1. So that would be this graph right here, number 16. So number 16 goes with number 16. That makes it easy. And then we got to look at 18 and 22 because they both have the same vertical, but they do have different horizontals. So for number 18, both of the asymptotes are at 3. So it wouldn't be 13, but it would be 21. Both the asymptotes are at 3. So by process of elimination, number 22 has to go with 13, and that makes sense because the vertical asymptote is at 3 and the horizontal asymptote is at -2. So we have matched all those problems.